You've never once felt yourself move through the cosmos in your entire life. As you sit perfectly still watching this screen, your senses assure you that you are resting on a solid, unmoving foundation. That feeling of absolute stillness is a sensory lie. In reality, you are plunging through a thick, invisible cosmic ocean at speeds that defy human imagination. You're tearing through the seething fabric of the quantum vacuum, a violently boiling sea of energy that fills every corner of empty space. This immense invisible friction gives weight to every atom in your body, anchoring your physical existence. You're adrift in the most chaotic storm imaginable, entirely blind to the immense forces roaring just beneath the surface of reality. Fortunately, nature beautifully shields our fragile minds from this overwhelming turbulence. But this protective illusion can only last so long before the truth begins to surface. Today you'll find out what the vacuum of space really is, and why it might be the most violent and unstable force in existence. For centuries, humanity looked up at the stars and imagined a peaceful, completely empty stage where the cosmic drama gracefully plays out. We mistakenly thought the vast dark gaps between the galaxies were simply nothingness. Yet the closer we look into the abyss, the more we realize that this emptiness is an illusion hiding a terrifying reality. It is a restless, shifting entity that governs the fate of everything we know. Before we set off, one question for you. Where in the world are you watching the sky from? And what time is it where you are? Tell us in the comments below. And if you love wandering through the night sky, subscribe to the channel. That's what keeps this work going. Let's dive right into the quantum void. To understand the terrifying instability of our universe, we first have to look at humanity's long and troubled relationship with absolute nothingness. For thousands of years, the concept of a true vacuum was considered a philosophical impossibility. The prevailing dogma, inherited from Aristotle, stated flatly that nature abhors a vacuum. If you removed all matter from a space, your senses suggested that something else would instantly rush in to fill the void. Space could never truly be empty. This comforting belief held civilization's worldview together. The universe was full, ordered, and entirely predictable. Then, in 1643, a brilliant Italian physicist named Evangelista Torricelli decides to challenge this ancient assumption. Working in Florence, Torricelli takes a glass tube about a meter long and fills it completely with heavy, toxic liquid mercury. He places his finger over the open end, turns the tube upside down and plunges it into a wide basin also filled with mercury. When he removes his finger, something astonishing happens. The heavy column of mercury does not entirely empty into the basin. It drops down and stops at a height of exactly 76 centimeters. But the real shock is not the liquid itself, it is the space left behind at the very top of the sealed glass tube. What exactly is inside that empty space? There is no air, no water, no known substance of any kind. Torricelli has just created the very first physical vacuum in human history. He proves, through a beautifully simple physical apparatus, that absolute nothingness is not just a philosophical trick. It is a real, measurable spatial structure that can be isolated and studied in a laboratory. For the next 3 centuries, this Torricelli vacuum becomes the foundational stage of classical physics. Isaac Newton and his successors build a magnificent clockwork model of the cosmos based on this concept. In their eyes, the universe is a giant, perfectly empty theatre. The stars, planets, and moons are the actors moving across this sterile stage, governed by the strict, unchanging laws of gravity and motion. If you had asked any late 19th century physicist, they would have told you that the scientific community was convinced that everything was finally solved. The basic mechanics of reality were completely understood, and all that remained was to measure the next few decimal places. The universe was considered a safe, stable, and deeply boring place. The void was just an empty box, a passive container for the matter that truly matters. But as the 20th century dawns, the newly born quantum revolution begins to whisper that the empty stage is hiding a profound secret. The first major crack in the classical dogma appears through the elegant mathematics of a quiet, incredibly brilliant theorist. In 1928 at Cambridge University, Paul Dirac sets out to combine the new rules of quantum mechanics with Albert Einstein's theory of special relativity. He writes down an equation to describe the behavior of the electron. The math is flawless and exceptionally beautiful. However, it harbors a bizarre anomaly. Dirac's equation yields not just positive energy solutions, but also negative energy ones. At that time, most physicists dismiss these negative solutions as a mere mathematical artifact, a glitch in the algebra that has no physical meaning. But Dirac trusts the elegance of his mathematics over the common sense of his era. He makes a wildly bold prediction. These negative solutions mean that for every particle of matter, there must exist an exact twin with opposite charge. He predicts the physical existence of antimatter. This implies that the vacuum is not an empty box. It is a pregnant reservoir capable of giving birth to opposites. Just 4 years later, in 1932, an experimental physicist named Carl Anderson is working at the California Institute of Technology. Anderson builds a specialized cloud chamber to study high-energy cosmic rays raining down from the sky. This apparatus is a sealed glass cylinder filled with supersaturated alcohol vapor, completely surrounded by extremely powerful electromagnets. When a charged particle passes through the chamber, it leaves a visible trail of condensed vapor, while the magnetic field forces the particle to curve. The direction of the curve reveals the particle's electrical charge. One day, Anderson is looking at a fresh photographic plate from the chamber. He sees a track that looks exactly like an electron. The mass is identical, but the trail curves sharply in the wrong direction. It is bending exactly as a positively charged particle would. Imagine you're standing in that laboratory, staring at the impossible evidence. In this frozen moment of discovery, the theoretical ghost steps out of the chalkboard and into reality. Anderson has discovered the positron. Antimatter is entirely real. The sterile, empty stage of classical physics is shattered forever, replaced by a dynamic, creative void where matter and antimatter can spontaneously emerge from the invisible depths. Yet, the scientific establishment is still not prepared for the true violence of the quantum vacuum. The ultimate blow to the dogma of empty space arrives in 1947 at Columbia University. Two physicists, Willis Lamb and Robert Rutherford, design an incredibly precise experiment heavily inspired by the advanced radar technologies developed during the Second World War. They direct a beam of hydrogen gas through a vacuum chamber and bombard it with carefully tuned microwave radiation. According to Paul Dirac's highly celebrated theory of the electron, two specific suborbits in the second energy level of a hydrogen atom should possess exactly the same energy. They should be perfectly identical, but as Lamb and Rutherford run the microwave beam, they measure a tiny, undeniable anomaly. They find a minuscule energy difference between these two levels, a shift corresponding to a frequency of 1057 MHz. This tiny discrepancy goes down in history as the Lamb shift. The cause of this shift is absolutely terrifying for anyone who believes in a peaceful universe. If you zoom in close enough to the atomic nucleus, you see that the space is not empty at all. It is a violently boiling sea of virtual particles. In the tiniest fractions of a second, countless virtual electron-positron pairs are constantly popping into existence and annihilating each other. These ghostly pairs are swarming around the real electron, jostling it, vibrating it, and slightly pushing its energy level upward. The vacuum is alive. It is a chaotic, raging storm of quantum fluctuations that physically alters the structure of the atom. The following year, in 1948, a physicist named Hendrik Casimir at the Phillips Research Laboratories takes this nightmare to its logical conclusion. Casimir predicts that if you place two perfectly smooth, uncharged metal plates extremely close together in an absolute vacuum, something bizarre happens. The boiling sea of virtual particles outside the plates will exert a greater pressure than the sea trapped inside. An invisible, ghostly force born purely from the vacuum will push the plates together. The void itself has a physical pressure. It can reach out and crush objects. The classical dream of a stable, empty universe is officially dead. The stage is actually a beast, and yet, however bizarre this boiling quantum sea appears, it is still playing by a strict set of rules. As long as the virtual particles repay their energy debt and vanish instantly, the overall stability of the cosmos seems secure. And this is where the logic falls apart. That assumed cosmic security only makes sense once you understand the invisible ocean that actually gives you weight. By the mid-20th century, physicists had reluctantly accepted that the vacuum was a boiling sea of virtual particles, constantly popping in and out of existence. But they still believed that these tiny fluctuations were just a superficial froth on top of a stable, deeply anchored reality. If you could somehow average out all that microscopic chaos, the underlying fabric of the universe should still be a peaceful, zero-energy baseline. However, nature had an even more profound shock waiting in the shadows. The resolution to this chaotic picture came from trying to answer a completely different, supposedly unrelated question: why does anything in the universe have mass? In 1964, a group of theorists, including Peter Higgs, François Englert, and Robert Brute, proposed an incredibly bold idea. They suggested that the entire universe, from the darkest void to the space between your atoms, is permanently flooded with a dense, invisible energy field. In this radical new vision, particles do not possess mass on their own. Instead, as they travel through this ubiquitous field, they experience a kind of cosmic drag, a persistent friction that slows them down and gives them weight. If you think of a fast-moving fish swimming through water, the water provides the resistance. In the cosmos, the vacuum itself is the water. This meant the vacuum was not just bubbling with temporary particles, it was permanently saturated with a thick, syrupy substance that anchored everything. The empty space was actually the heaviest, most solid thing in existence. For nearly half a century, this profound theory remained an elegant mathematical dream, waiting for engineering to catch up. To prove that the vacuum was fundamentally thick, humanity had to build the most complex machine ever conceived. In 2012, this search culminated at CERN with the Large Hadron Collider. The physical apparatus required to tear apart the vacuum is staggering. Imagine a flawless circular vacuum tube, 27 kilometers in circumference, buried 100 meters beneath the border of Switzerland and France. Inside this frozen ring, beams of protons are accelerated by incredibly powerful superconducting electromagnets until they reach 99.999% of the speed of light. They are then steered to collide head-on with unimaginable violence. Surrounding these collision points are the Atlas and CMS detectors. These are not simple cameras. They are cylindrical behemoths the size of multi-story buildings, packed with tens of millions of microscopic silicon pixel sensors and massive, supercooled liquid argon calorimeters. When the protons smash into each other, they momentarily concentrate so much energy into a tiny point that they rip a tear in the fabric of the vacuum itself. The detectors capture the subatomic shrapnel flying out of the blast, recording the track's momentum and energy of trillions of particles in fractions of a second. Hidden deep within this digital debris, the researchers finally found the signature they were looking for. They discovered the Higgs boson, a ripple in the invisible field. They proved beyond any doubt that the vacuum is indeed a thick, permanent ocean. Yet, this monumental triumph only deepened the historical crisis surrounding the nature of empty space. While the experimentalists at CERN were smashing protons, another quiet war had been raging among theoretical physicists regarding the actual energy contained within this vacuum. The roots of this conflict stretch back to Albert Einstein and Niels Bohr. Early in the 20th century, Einstein had struggled with his equations of general relativity, which seemed to suggest that the universe should collapse under its own gravity. To fix this, he introduced a mathematical patch called the cosmological constant, representing an intrinsic repulsive energy built directly into the fabric of empty space itself. It was an outward push from the vacuum. When Edwin Hubble later proved with his telescope that the universe was expanding, Einstein famously abandoned this constant allegedly calling it his biggest blunder. He wanted the vacuum to be energetically neutral, but the pioneers of quantum mechanics, led by figures like Bohr, mathematically insisted that the vacuum could not be neutral. The equations of quantum field theory demanded that the empty space must be vibrating with infinite energy. For decades, the two great pillars of physics, relativity and quantum mechanics, stood in awkward contradiction over the true nature of nothingness. Relativity wanted a quiet, smooth void. Quantum mechanics demanded a violently energetic one. In the late 1990s, when astronomers studying distant supernovae discovered that the expansion of the universe was actually accelerating, Einstein's supposedly blundering concept returned with a vengeance. This mysterious dark energy pushing the galaxies apart behaved exactly like the vacuum energy he had discarded. The vacuum was undeniably pushing back. If the vacuum was indeed thick with energy and fields, it should theoretically act as a braking system for anything trying to cross it at extreme speeds. So, according to the leading theories of the time, known as the Griesenzatzepin-Kuzmin limit, there was a strict universal speed limit. Any particle travelling too fast through the cosmos would inevitably crash into the faint glowing radiation left over from the Big Bang. The vacuum would drag it down, stripping away its energy. No particle could survive a long journey at such ludicrous speeds, but nature loves to shatter our arrogant assumptions. In 1991, a team led by Pierre Sokolsky at the University of Utah was operating the Fly's Eye Observatory. The physical setup was mesmerizing. Located in the desolate, pitch-black expanse of the Utah desert, the observatory consisted of 67 massive fly-like spherical mirrors and thousands of sensitive light-multiplying tubes staring blindly into the night sky. On one cloudless October night, an ultra-high-energy cosmic ray slammed into the Earth's atmosphere, striking nitrogen molecules and triggering a massive cascading waterfall of blue fluorescent light. The mirrors collected this faint glow and sent the data to the computers. When the researchers analysed the numbers, they were completely stunned. The particle, a single microscopic proton, carried a kinetic energy of 320 exa-electron volts. This was the equivalent of a baseball thrown at 100 km per hour, packed entirely into an invisible speck. They aptly named it the "Oh my God" particle. It had blasted through the allegedly thick, braking vacuum of space, completely ignoring the theoretical speed limits. The vacuum was not just thick, it was violently selective, allowing unimaginable monsters to tear through it unharmed. The most chilling twist in this historical saga did not come from a massive particle accelerator or a deep space telescope. It came from a chalkboard at Harvard University. In 1977, a legendary theoretical physicist named Sidney Coleman was quietly investigating the mathematical properties of these omnipresent quantum fields. Unlike the vast teams of engineers at CERN, Coleman needed no heavy machinery, only his brilliant mind and a piece of chalk. He published a landmark paper titled The Fate of the False Vacuum, systematically exploring the stability of the invisible fields that fill the cosmos. Coleman realized that fields, like water running down a mountain, naturally seek the lowest possible energy state, a condition physicists call the true vacuum. But the mathematics allowed for a terrifying alternative. A field could roll down the mountain and get trapped in a small elevated crater along the way. In this shallow dip, the field would appear completely stable and at rest. It would feel like the bottom. But it would only be a local minimum, not the absolute floor of reality. Coleman called this deceptive temporary resting place the false vacuum. If our universe is sitting in a false vacuum, then the stable laws of physics we observe, the mass of the electron, the strength of gravity, the chemistry of your body, are just a temporary localized illusion. They are the rules of the shallow crater, not the rules of the true ocean floor. The discovery of the Higgs boson decades later added a terrifying physical weight to Coleman's purely theoretical warning. When scientists finally measured the exact mass of the Higgs boson and combined it with the mass of another fundamental particle called the top quark, the equations balanced precisely on a knife's edge. The numbers suggested that the invisible ocean anchoring our reality is not at the bottom of the mountain. It is suspended in a temporary trap. We are living in a false vacuum. The crisis of the empty stage had been solved. We now knew exactly what filled the void and how it gave mass to our world. However, the confirmation of this invisible field raised an even more troubling puzzle. Yet the vacuum isn't entirely what it seems. To truly comprehend the terrifying deception of empty space, we must dissect this invisible entity into 3 distinct anatomical layers. Think of reality as a vast bottomless ocean. The first layer is the violent boiling surface known as the quantum foam. Beneath that lies the second layer, a thick, syrupy gravitational anchor that permanently gives mass to the universe. And finally, hidden at the absolute depths is the third layer, the razor-thin precipice of the false vacuum, where the laws of physics are suspended in a temporary trap. We will eventually descend to that terrifying third layer, but our journey must begin at the turbulent surface. We must first understand the boiling quantum foam. For centuries, human intuition has been severely misled by a profound cosmic myth. It is the widespread belief that the vacuum of space is an absolute dead nothingness. This classical misconception was inherited from the philosophical traditions of Aristotle and the rigid mechanical models of Isaac Newton. It suggests that if you remove all the stars, planets, gas and light from a region of space, you are left with a sterile, empty box. Even today, popular culture and basic textbooks often reinforce this comfortable illusion, depicting space as a silent, passive stage where the real actors, matter and energy, perform. But quantum field theory proves that this intuitive assumption is entirely wrong. Imagine taking a thick, impenetrable steel box and pumping out every single atom of gas. You shield it from all external radiation, blocking every cosmic ray, every stray photon, and every magnetic field. Finally, you cool the interior down to absolute zero, the ultimate temperature where all classical thermal motion completely stops. According to classical physics, the inside of that box should be the ultimate peaceful void. But if you were to zoom in with a hypothetical infinitely powerful microscope, you would see a scene of absolute chaos. The void inside that box is not dead. It is a violently boiling soup of quantum fields, constantly vibrating with immense restless energy. Even at absolute zero, the vacuum possesses a baseline zero-point energy that cannot be erased or calmed. The mechanics driving this restless storm are rooted in one of the most bizarre rules of the universe, the Heisenberg uncertainty principle. In the macroscopic world we inhabit, the law of conservation of energy is absolute. You cannot create energy out of nothing, and you cannot destroy it. But in the microscopic quantum vacuum, this strict law is constantly broken through a brilliant cosmic accounting trick. The uncertainty principle states that there is a fundamental fuzziness to the universe. You can never perfectly know both the energy of a system and the exact time it possesses that energy. Because of this inherent fuzziness, the vacuum is allowed to temporarily borrow energy from the bank of nothingness. When the vacuum borrows this energy, it uses it to spontaneously create a pair of particles, usually a matter particle and its exact antimatter twin, such as an electron and a positron. These are known as virtual particles. They pop into existence out of absolute nowhere, born purely from the borrowed energy of the void. However, the cosmic bank operates on incredibly strict, merciless terms. The more energy the vacuum borrows to create a heavy particle pair, the shorter the time it is allowed to keep that energy. For a standard electron-positron pair, their allowed lifespan is incomprehensibly short, roughly a billionth of a trillionth of a second. Within that minuscule fraction of an instant, the two ghostly twins must violently crash back into each other, annihilate and repay their energy debt to the vacuum before the universe's accounting system catches the discrepancy. This frantic cycle of creation and annihilation is happening everywhere, at every moment, in every single cubic millimeter of space, including the empty gaps between the atoms in your own body. This brings us to a second, equally persistent myth surrounding the nature of empty space. For decades, some physics textbooks and popular science articles have perpetuated the idea that these virtual particles are not real. They're often dismissed as mere mathematical tricks, pedagogical tools, or convenient internal lines on a Feynman diagram used to make complex calculations easier. The myth suggests that because these particles exist for such a short time and cannot be directly captured in a conventional detector, they are just abstract mathematical ghosts with no physical reality. But this dismissive view is dangerously incorrect. Virtual particles are absolutely real, and they have profound, measurable physical effects on our macroscopic world. The boiling foam of virtual particles is not a theoretical abstraction. It is a physical force that shapes the structure of reality. The Casimir effect, accurately measured in the late 1990s, physically demonstrated this phenomenon. If you place two uncharged metal plates incredibly close together, the boiling sea of virtual particles outside the plates exerts a greater pressure than the constrained sea trapped inside. This difference in quantum pressure physically pushes the solid metal plates together. Furthermore, the Lamb shift proved that these virtual ghosts constantly swarm around the real electrons in every atom, jostling them and physically shifting their energy levels. Without the constant physical interference of these supposedly fake virtual particles, the chemical bonds holding your DNA together would behave entirely differently. You owe your very biological existence to the physical reality of these quantum ghosts. When you push human understanding down to the ultimate limit of scale, known as the Planck length, the concept of a smooth vacuum completely disintegrates. This distance is so incredibly small that it is to an atom what an atom is to the entire solar system. At this extreme microscopic scale, space and time themselves become violently twisted, torn, and tangled by the endless energy fluctuations. Theoretical physics refers to this state as quantum foam. Here, the comfortable everyday concepts of left and right, up and down, before and after, lose all logical meaning. The fabric of reality is a chaotic, raging storm, constantly bubbling and ripping itself apart under the immense strain of zero-point energy. The emptiness is a beast that refuses to sit still, a relentlessly creative and destructive force that defies everything we consider normal. The first anatomical layer of the vacuum shatters our comforting illusion of a peaceful void. It reveals that we are not floating through a silent, empty theatre, but rather navigating a frantic, boiling ocean of temporary ghosts and stolen energy. Yet, as chaotic and violent as this quantum foam appears, it is only the restless surface of the cosmos. It is the superficial froth dancing on top of a much deeper, far more powerful mechanism. This microscopic storm alone cannot explain why stars burn, why planets orbit, or why you are physically anchored to the ground beneath your feet. To understand the true weight of our physical existence, we must dive beneath the boiling surface and confront the second anatomical layer of the vacuum. But that's nothing compared to the permanent heavy ocean anchoring the entire universe. To comprehend the sheer physical weight of reality, we first have to look at the invisible molasses that permanently surrounds us. In the previous anatomical layer, we explored the boiling quantum foam, a frantic world of temporary ghosts blinking in and out of existence. But if the entire universe were made solely of that chaotic surface froth, nothing would ever hold together. There would be no stars, no planets, and no human bodies. The universe requires a stabilizing force, a thick, omnipresent anchor to slow things down. This brings us to the second anatomical layer of the vacuum, the Higgs field. Unlike the temporary virtual particles of the first layer, this second layer is a permanent, syrupy background that saturates every single cubic millimeter of the cosmos. It does not blink out of existence. It is always there, waiting in the dark. To understand how this invisible, syrupy anchor works, physicists often use a mechanical analogy known as the Mexican hat potential. Imagine a giant sombrero with a high, rounded central peak and a deep circular brim surrounding it. At the very moment of the Big Bang, the universe was unfathomably hot and dense. During this fiery infancy, the Higgs field was perfectly symmetrical. It was perfectly balanced at the very top of the sombrero's peak. At this exact peak, the field's value was precisely 0. Because the field was at zero, it exerted absolutely no drag on any particles. In that primordial inferno, every single elementary particle zipped through the cosmos at the absolute speed of the light. Nothing had any mass. There was no solid matter, only an endlessly expanding, blinding flash of pure, weightless energy. But this perfect symmetry was fundamentally unstable, much like a sharp pencil balancing perfectly on its tip. As the universe rapidly expanded, it began to cool down. Eventually, the temperature dropped below a critical threshold, and the Higgs field could no longer maintain its precarious balance at the top of the hat. It rolled down the slope and settled into the deep circular brim at the bottom. This event, known as spontaneous symmetry breaking, permanently altered the mechanical structure of the vacuum. The brim of the hat represents a new stable baseline for the universe. However, unlike the top of the peak, the brim does not have a zero value. The field settled into a permanent non-zero energy state, locking in at approximately 246 giga-electron volts. Because the vacuum now possessed this permanent thick energy value, the rules of motion changed forever. As fundamental particles like quarks and electrons tried to move through this newly saturated space, they began to wade through the syrupy field. The field clung to them, creating a cosmic friction. This invisible drag, born entirely from the structure of the vacuum itself, is what we experience macroscopically as mass. The heavier a particle is, the more strongly it interacts with this background molasses. This profound realization destroys another deeply ingrained myth about the cosmos. High school textbooks often portray the inside of an atom as a tiny dead solar system. They show a solid, heavy nucleus sitting in the center, with electrons orbiting it through a vast, completely empty space. The myth suggests that the mass of your body comes from the solid, physical building blocks inside those atoms. But quantum mechanics reveals a terrifying truth. If you take a proton, the heavy heart of the atom, and weigh the 3 tiny quarks inside it, their combined resting mass accounts for barely 1% of the proton's total weight. So where does the other 99% of your mass come from? It comes directly from the vacuum. The empty space inside the proton is not a static void. It is a violently raging storm of virtual quarks and gluons, the particles that bind the nucleus together. This furious kinetic energy, trapped within the microscopic boundaries of the atom, generates 99% of your physical weight. You're not made of solid, dead matter. Your body is quite literally composed of trapped, boiling vacuum energy. The solid ground you walk on and the screen you are looking at are masterful illusions. They are created by the invisible friction and furious energy of the empty space surrounding you. Yet, this majestic anchor hides a terrifying mathematical contradiction. If the vacuum is saturated with this heavy Higgs field and the endlessly boiling quantum foam, how much total energy is actually packed into a single cubic meter of empty space? When theoretical physicists run the equations of quantum field theory, they add up all the zero-point energy of the virtual particles and the baseline values of the fields. The resulting mathematical answer is apocalyptic. The equations predict that 1 cubic meter of the vacuum should contain 10 to the power of 113 joules of potential energy. To put that into perspective, that is a 1 followed by 113 zeros. It is a number so unimaginably large that if it were true, the sheer gravitational weight of that vacuum energy would instantly crush the entire observable universe down to a microscopic singularity. But obviously we are here. The universe is not crushed. When astronomers point their telescopes at the distant galaxies and measure the actual expansion of the cosmos, they can calculate the true physical energy density of the vacuum, often called dark energy. The measured reality is completely different from the theoretical prediction. The telescopes reveal that the true vacuum energy is only about 10 to the power of -9 joules per cubic meter. That is a decimal point followed by 8 zeros and a 1. This creates a horrifying gap between human theory and cosmic reality. The mathematical prediction is larger than the physical reality by an astonishing factor of 10 to the power of 120. This catastrophic discrepancy is famously known as the vacuum catastrophe. It is widely considered the single most embarrassing miscalculation in the history of theoretical physics. Something out there, some unknown, invisible, mechanical process, is brutally suppressing the apocalyptic energy of the vacuum. A mysterious cancellation mechanism is aggressively erasing almost all of that zero-point energy. It leaves behind only the tiniest fragile fraction, just enough to slowly, gently, push the galaxies apart over billions of years. We have now mapped the first two anatomical layers of nothingness. We have waded through the boiling quantum foam of the first layer, and we have touched the thick, syrupy anchor of the second layer sitting in the brim of the Mexican hat. The universe seems to have settled into a strange mathematical compromise. The mass is anchored, the vacuum energy is mysteriously suppressed, and the cosmos appears stable enough to allow humans to exist. But what if this stable brim of the hat isn't the true bottom of the mountain at all? That apparent cosmic stability only makes sense once you recognize the invisible trap we are caught in. We have explored the boiling quantum foam and the syrupy Higgs field that gives us mass. We imagine this field resting comfortably in the deep brim of the Mexican hat, providing a solid foundation for reality. But this brings us to the third and most terrifying anatomical layer of the vacuum, the precipice of the false vacuum. The brim of the hat is not the true floor of the universe. It is merely a shallow, elevated crater on the side of a much larger cosmic mountain. The field is stuck in this local minimum, protected by a high energetic wall that prevents it from sliding further down. The absolute bottom of the mountain, where energy is truly at its lowest possible state, is called the true vacuum. And we are not in it. To understand the mechanics of this trap, you must look at how things move in the quantum world. In classical everyday physics, if a heavy boulder is resting in a deep valley, it will stay there forever unless a massive external force pushes it up and over the surrounding mountains. But in the bizarre realm of the quantum vacuum, the rules of motion are radically different. Thanks to the inherent fuzziness of the Heisenberg uncertainty principle, a quantum field does not need to climb over the mountain to reach the lower valley. Given enough time, the mathematics of probability allow the field to spontaneously punch a hole right through the solid barrier. It can simply materialize on the other side, dropping instantly into the true vacuum. This terrifying loophole is called quantum tunneling. This realization destroys perhaps the most comforting myth humanity has ever constructed. Rah! That myth is the widespread belief that the universe is permanently stable and will remain exactly as it is forever. Because human lifespans are so incredibly short and the stars have burned steadily for billions of years, we naturally assume that the laws of physics are set in stone. But the precise measurements of the top quark and the Higgs boson reveal a horrifying truth. We are living in a metastable state. The cosmos is balancing on a razor's edge. The universe is not a permanent fortress. It is a ticking time bomb waiting for a single, microscopic quantum fluctuation to trigger the final collapse. If this quantum tunneling event occurs at any random point in the vastness of space, the mechanical consequences are absolute. A microscopic bubble of true vacuum will instantly materialize, but it will not stay microscopic. The outer boundary of this new reality, known as the bubble wall, will immediately begin to expand violently outward in all directions. Because this wall is driven by the pure, unadulterated energy of the vacuum itself, it accelerates instantly to the absolute speed of light. The mechanics operating at the edge of this bubble wall are beyond apocalyptic. As the wall sweeps across the cosmos, it does not just destroy matter, it completely rewrites the fundamental laws of physics. Behind the wall, inside the true vacuum, the Higgs field drops to a radically different value. The intricate balance of the electromagnetic and strong nuclear forces is instantly shattered. If the wall passes through you, the electrons in your body might suddenly lose all their mass and fly away. They might also become so unimaginably heavy that they collapse directly into the nucleus. In less than a fraction of a nanosecond, every single atom, molecule, and chemical bond that makes up your body, your planet, and your star system would simply cease to exist. There would be no pain, no explosion to watch, and absolutely no early warning. The destruction arrives at the exact same speed as the light that would let you see it coming. To grasp just how perfectly the quantum vacuum can erase physical reality, we only need to look at its most violent mechanical process, the annihilation of matter and antimatter. When a particle of matter touches its antimatter twin, the conversion of mass into energy is absolutely flawless. In a nuclear bomb or the core of the sun, only a tiny fraction of 1% of the mass is actually converted into energy. But when antimatter meets matter, the efficiency is exactly 100%. If you had just a single gram of antimatter and touched it to a gram of regular matter, the resulting annihilation would instantly release a staggering 180 trillion joules of pure radiation. That is the kinetic equivalent of 3 atomic bombs going off simultaneously, born from an object the size of a paperclip. The bubble wall of the true vacuum would unleash an annihilation of the physical laws themselves that is even more absolute and unforgiving than antimatter. The relentless destructive mechanics of the vacuum spare absolutely nothing, not even the most terrifying monsters of the cosmos. Consider the behavior of the quantum vacuum at the event horizon of a black hole. Stephen Hawking proved that the boiling quantum foam does not stop at the edge of a singularity. When a pair of virtual particles spontaneously forms exactly on the razor-thin boundary of the event horizon, the extreme gravity pulls one particle inside, while the other is left stranded on the outside. Without its partner, the stranded particle cannot annihilate and repay its energy debt. It is forced to become a real, permanent particle and radiates away into space. But the universe demands its accounting to balance. The energy to create that new particle is brutally subtracted from the mass of the black hole itself. Through this process, known as Hawking radiation, the vacuum slowly, methodically bleeds the black hole to death over trillions of years until it evaporates into nothingness. The vacuum always wins. Despite mapping all these intricate, deadly mechanisms, there is a massive dark hole in our understanding. The ultimate unknown lies at the very bottom of the microscopic world. When theoretical physicists attempt to merge the equations of gravity with the boiling chaos of the quantum vacuum at the Planck scale, the mathematics completely break down. The equations produce infinite values and nonsensical answers. We simply do not know how gravity operates inside the quantum foam, nor do we know the precise shape of the true vacuum waiting at the bottom of the cosmic mountain. The exact trigger that will start the tunneling event remains hidden in the mathematical darkness. You might comfort yourself by thinking, this is just a wild, theoretical hypothesis, a string of complex mathematics that has no bearing on physical reality, and that our solar system is perfectly safe from such abstract doom. Except none of that is true. Yet, the mathematics of doom aren't entirely what they seem. We have dissected the violent, boiling anatomy of the vacuum, and we have stared into the terrifying abyss of the bubble wall. The universe, according to our most precise physical theories, is a hostile, raging storm of quantum energy that is constantly threatening to collapse into a true vacuum. But as we pull back and look at the cosmos as a whole, we are confronted by a series of existential contradictions. The universe is riddled with paradoxes where our logical expectations violently clash with observed reality. The most glaring of these contradictions is the central paradox of our existence, a mathematical nightmare known as the vacuum catastrophe. To understand this central paradox, you must weigh the expectation of quantum mechanics against the physical reality of the night sky. The expectation is simple and brutal. The equations of quantum field theory demand that every single point in the vacuum of space should be packed with an infinite seething density of zero-point energy. If you take that theoretical energy density and apply Einstein's laws of general relativity, the sheer gravitational weight of that empty space should have instantly crushed the entire universe into a microscopic singularity the moment it was born. Alternatively, if the pressure was directed outward, it should have ripped every galaxy, star, and atom apart in a fraction of a second. So, according to the flawless mathematics of quantum mechanics, a large, stable, and slowly expanding universe like ours is an absolute physical impossibility. Yet, The reality is that you are sitting here, reading or listening to this, existing in a universe that has slowly and majestically expanded for almost 14 billion years. The actual measured energy of the vacuum is a staggering 120 orders of magnitude smaller than what the foundational equations of physics predict. This is not a simple calculation error. It is a fundamental paradox of existence. The cosmos is theoretically required to be a chaotic instant death trap, but it practically functions as a serene, life-bearing sanctuary. Some unknown, invisible mechanism is perfectly suppressing the apocalyptic energy of the vacuum, cancelling out the destruction with such unimaginable precision that it leaves behind just a tiny, gentle push of dark energy. The paradox is that the most violent force in existence is actively holding back its own power, allowing us the quiet time to exist. This central contradiction leads us directly into a second, equally staggering puzzle, the paradox of existence itself. When physicists run the mathematical models of the Big Bang, they find another expectation that clashes violently with reality. At the moment of creation, the unimaginably hot, dense energy of the early universe condensed into physical particles. According to the absolute laws of symmetry in physics, energy must always condense into exactly equal amounts of matter and antimatter. For every electron created, there must be a positron. For every quark, an antiquark. The logical expectation is a story of perfect immediate annihilation. As the universe expanded and cooled, these equal and opposing armies of matter and antimatter should have crashed into each other. Because their collision converts 100% of their mass back into pure energy, the two opposing forces should have perfectly and entirely destroyed each other. The resulting universe should be a sterile, dead void, filled with absolutely nothing but wandering, weightless photons of light. In a perfectly symmetrical, mathematically flawless universe, there should be no stars, no planets, no carbon, and absolutely no biological life. But the physical reality is profoundly different. When we look out into the observable universe with our most powerful telescopes, we see hundreds of billions of massive galaxies, all made entirely of regular matter. The antimatter is almost completely gone. How did this happen? Physicists have discovered that during the primordial annihilation, there was a microscopic, completely irrational asymmetry. For roughly every 1 billion particles of antimatter produced, the universe inexplicably created 1,000,000,001 particles of regular matter. When the great cosmic slaughter occurred, the 1 billion particles of antimatter destroyed the 1 billion particles of matter, leaving nothing but light. But that single, solitary extra particle of matter was left standing in the ruins. It had no antimatter partner left to destroy it. It survived. The paradox of your existence is that every single atom in your body, the oxygen in your lungs, and the iron in your blood is the direct result of a cosmic rounding error. We owe our entire physical reality not to the flawless symmetry of nature's laws, but to a tiny, inexplicable flaw in the universe's accounting system. We are the microscopic remainder of a broken symmetry. We should not exist, yet we do. This brings us to a third contradiction, one that challenges your everyday sensory experience, the paradox of empty matter. Human intuition is built on the expectation of solidity. When you knock your knuckles against a wooden desk or stand on a concrete floor, your brain tells you that you are interacting with dense, solid objects. You expect the building blocks of reality to be hard, permanent little spheres of matter tightly packed together. For centuries, even scientists believed that the inside of an atom was a miniature solid solar system, with a heavy, dense nucleus sitting in the center. But the reality of quantum mechanics shatters this illusion of solidity. If you were to zoom in on the atoms that make up that solid wooden desk, you would find that they are almost entirely empty space. The nucleus at the center is unfathomably small, and the electrons orbit at vast, empty distances. But the paradox goes even deeper than just the empty space between the particles. If you zoom into the solid nucleus itself and look at the protons and neutrons, you find the most shocking truth of all. The actual physical mass of the quarks inside a proton accounts for only about 1% of its total weight. The other 99% of the mass in that solid wooden desk, and in your own body, comes from the furiously boiling kinetic energy of the vacuum trapped inside the proton. The space inside the atom is not empty. It is a raging kinetic storm of virtual particles popping in and out of existence, bound by the intense energy of the strong nuclear force. When you touch a solid object, you're not actually touching solid matter. The electrons in your hand are being repelled by the electrons in the desk through the exchange of invisible virtual photons. The sensation of a hard, solid surface is a complete biological hallucination. You're feeling the repulsive force of empty space pushing back against you. We live our lives navigating a series of sensory illusions and mathematical contradictions. We feel solid, but we are made of empty, boiling vacuum energy. We exist, but the laws of perfect symmetry dictate that we should have been annihilated at the dawn of time. We look up at a calm, stable sky, but the foundational equations of physics demand that the vacuum should have crushed the entire universe in a fraction of a second. The cosmos is a delicate, fragile tightrope walk over an abyss of infinite destructive energy. We survive only because of microscopic imbalances and mysterious cancellations that we still do not fully comprehend, and this is where the logic finally breaks down. To understand how deeply this logic is broken, we first have to look at the sky's most impossible traveller. When physicists look up at the night sky, they rely on a strict set of rules that dictate how energy and matter should behave across vast cosmic distances. One of the most absolute rules in astrophysics is a theoretical speed limit known as the Grayson-Zatsepin-Kuzmin limit. This limit is based on the realization that the vacuum of space is not truly empty, but rather flooded with a cold, ancient sea of photons left over from the Big Bang, known as the cosmic microwave background radiation. The logical expectation is that this radiation sea acts like a thick fluid for anything trying to move through it at extreme speeds. If an incredibly energetic particle, like a proton, is fired across the universe, it cannot travel forever without consequence. As it accelerates closer and closer to the speed of light, it begins to smash violently into those ancient photons. Each microscopic collision acts like a brake, sapping a tiny amount of energy from the traveling particle. According to the flawless mathematics of this limit, no particle should ever be able to arrive at Earth with an energy exceeding roughly 50 exa-electron volts. The friction of the cosmic microwave background should have dragged it down to a safe, predictable speed long before it reached our atmosphere. But reality once again utterly defies the mathematics. On a dark, cloudless night in October 1991, the Fly's Eye Observatory in the Utah desert detected an event that sent shockwaves through the scientific community. A single proton smashed into the Earth's atmosphere, triggering a massive cascade of secondary particles and a brilliant flash of blue fluorescent light. When the computers calculated the kinetic energy of this single microscopic proton, the scientists initially thought their equipment was broken. The particle was carrying an unbelievable 320 exa-electron volts of kinetic energy. To translate that into a macroscopic scale, imagine taking a heavy leather baseball, winding up and throwing it at 100 kilometers per hour. Now take all the bone-crushing mechanical kinetic energy of that moving baseball and compress it down into a single microscopic point, a proton that is trillions upon trillions of times smaller than a grain of sand. The particle was moving at exactly 99 followed by 23/9% of the speed of light. It was traveling so fast that it was practically breaking the limits of special relativity. The researchers were so stunned by the data that they named it the "Oh my God" particle. This creates a terrifying supportive paradox. The mathematics of the Grayson-Zatsepin-Kuzmin limit dictate that this particle should not exist. It should have burned up or lost its energy crashing through the ancient sea of photons long before it reached Utah. Yet it arrived completely intact, carrying a lethal payload of kinetic energy. The paradox of the "Oh my God" particle forces us to ask a deeply unsettling question: how did it survive? And more terrifyingly, what kind of cosmic engine, lurking in the dark voids of space, is capable of generating magnetic shock waves powerful enough to accelerate a single proton to such impossible extremes. While we struggle to comprehend the impossible violence of these lone particles, an even larger paradox looms over the entire architecture of the cosmos. This is the paradox of the false vacuum. When you look out your window in the morning, the sun rises right on schedule. The seasons change, the stars maintain their fixed patterns, and the ground beneath your feet feels entirely permanent. Our classical intuition, built on millions of years of biological evolution, demands that the universe is a stable, finished product. We expect that the fundamental laws of nature are eternally locked in place, providing a safe, permanent theatre for life to exist. However, the deep quantum measurements of the Higgs boson and the top quark completely shatter this comforting illusion. The reality is that the universe is not sitting at the absolute bottom of its energy potential. We are not safe in the deep, unshakable valley of the true vacuum. Instead, we are precariously perched on an elevated shelf, trapped in a metastable state. The cosmos is essentially a ticking time bomb. The sheer existence of this metastable state is a paradox of time and perception. How can a universe that is constantly hovering on the razor-thin edge of absolute annihilation look so peaceful and unchanging? The answer lies in the terrifying illusion of deep time. For a human being, a lifespan of 80 years feels like an eternity. We look at the history of human civilization stretching back a few thousand years, and it seems incredibly ancient. But to the cosmos, thousands or even millions of years are less than the blink of an eye. The universe has been trapped on this false vacuum shell for nearly 14 billion years, and to us that feels like permanent stability. But in the grand quantum mechanical timeline, 14 billion years is just a temporary pause. The concept of metastability is common in chemistry and classical physics. Think of a piece of wood sitting in a room containing oxygen. It is stable for centuries, but the moment a tiny spark is introduced, the wood violently transitions into ashen gas, seeking a lower energy state. The universe itself is like that piece of wood, sitting in an incredibly vast room, waiting for the cosmic spark of quantum tunneling to initiate the final combustion. The quantum fluctuations that could trigger a tunneling event and spawn a catastrophic bubble wall might take trillions of years to align, or they might align tomorrow. The paradox is that our perception of a perfectly stable universe is simply a byproduct of our incredibly brief, fleeting existence. We are like mayflies living for a single day on the side of a dormant volcano, completely convinced that the mountain will never erupt simply because it hasn't happened in our short lifetime. We have now reached the terrifying conclusion of the mystery that we opened at the very beginning of this journey. We set out to discover what the vacuum of space really is, and why it might be the most violent and unstable force in existence. The answer is now brutally clear. The vacuum of space is not an empty container. It is not a sterile black void waiting to be filled with stars and planets. The vacuum is the true beating heart of reality, and it is a masterpiece of deception. It is a boiling, raging ocean of quantum foam, where ghostly virtual particles borrow energy and annihilate each other billions of times a second in a frantic cosmic accounting trick. It is a syrupy, omnipresent field that clings to our atoms, generating the invisible friction that we experience as solid mass. The vacuum creates the illusion that we are solid beings, while simultaneously reminding us that 99% of our weight is just trapped kinetic energy. It holds back an apocalyptic density of zero-point energy through a mysterious cancellation mechanism that defies all mathematical logic. And finally, it suspends our entire universe on an energetic precipice, waiting patiently for the inevitable moment when a microscopic quantum tunnel will open and a bubble wall of true vacuum will wipe the slate clean. The vacuum is not nothing. It is everything. It is the architect of our existence and the guaranteed executioner of our future. It is a force of such unimaginable complexity and violence that human mathematics repeatedly breaks down when trying to comprehend it. We live in a universe that mathematically should not exist, governed by laws that are balanced on the edge of a knife, surrounded by an emptiness that is more substantial and powerful than all the galaxies combined. The vacuum is the ultimate paradox. It is the creator that gives us the friction to exist, and the destroyer that will eventually erase the very laws of physics that allow us to think, breathe, and wonder. We have dissected the anatomy of nothingness, and we have survived the paradoxes of the quantum realm. But the terror of the cosmos does not end at the microscopic scale. When we pull our focus away from the invisible quantum fields and look at the universe on its grandest, most majestic scale, the true horror of our isolation becomes apparent. Even more troubling is what happens when you zoom out to look at the entire cosmic map. That terrifying isolation only makes sense once you recognize the sheer scale of the abyss surrounding us. We have spent our time trapped in the microscopic world, examining the boiling quantum foam and the syrupy Higgs field. But the human brain is biologically incapable of truly comprehending the mathematical reality of these quantum mechanics. Our minds evolved to understand the speed of a running predator, the weight of a stone, and the distance to the horizon. When we're confronted with the true mathematical dimensions of the cosmos, our neurological limits fail completely. To truly feel the crushing cognitive weight of the vacuum, we must abandon abstract equations. We must violently force the terrifying numbers of the universe into physical, macroscopic analogies that you can actually visualize. We must begin by scaling the concept of emptiness itself. The first step on this ladder of nothingness sits right on your desk. Consider the empty space inside a standard coffee mug. It contains roughly 300 milliliters of space, an easily digestible volume that your hands can manipulate. Now, we take our first violent step down the scale, zooming into the atomic structure of the ceramic mug itself. As we established earlier, the solid matter is mostly an illusion. To visualize the staggering emptiness inside a single atom, you must imagine a massive, towering professional football stadium. If you were to place a standard football directly on the center line of the field to represent the heavy atomic nucleus, the electrons would not be nearby. The electrons would be microscopic dust motes swirling chaotically in the absolute highest, most distant bleachers of the stadium. The vast, terrifying gulf of space between the football and those dust motes is the quantum vacuum, but now we must swing the pendulum violently in the opposite direction. We move from the microscopic void of the atom to the macroscopic void of the deep cosmos. When astronomers point their telescopes toward the constellation of Boötes, they do not see a dense cluster of galaxies. Instead, they stare into the Boötes void, a spherical ocean of darkness that is a staggering 320 million light-years across. According to the standard distribution of matter in the universe, a region of space that impossibly vast should contain tens of thousands of brilliantly burning galaxies. Instead, it is almost entirely terrifyingly empty, containing only a few dozen isolated lonely star systems. You have now travelled from the comforting emptiness of a coffee mug, down to the cavernous stadium-sized isolation of an atom, and finally up to a galactic graveyard so massive that it challenges our fundamental understanding of gravity. This staggering scale of distance fundamentally rewrites the rules of cosmic disasters. Consider the apocalyptic mechanics of the false vacuum decay that we mapped out earlier. Let us imagine a worst-case scenario. Imagine that the exact necessary quantum fluctuations finally align, but they do not align here. Instead, a true vacuum bubble punches through the fabric of reality in the center of the Andromeda galaxy, our closest major galactic neighbor. Because the boundary of this bubble is driven by the pure energy of the vacuum, the wall of destruction accelerates instantly to the absolute speed of light. It begins its relentless, unstoppable march toward the Milky Way, rewriting the laws of physics and annihilating every star, planet, and atom in its path. But Andromeda is located approximately 2.5 million light-years away from Earth. Because the absolute speed limit of the universe is the speed of light, that advancing wall of cosmic death will take exactly 2.5 million years to reach our solar system. The sheer terror lies in the scale of that delay. Think about the average human lifespan, which hovers around 80 years. A person is born, they experience childhood, they learn, they work, they grow old, and they die. That entire cycle of a human life must repeat itself consecutively over 31,250 times. Entire civilizations will rise, build massive monuments, fight brutal wars, slowly crumble into dust, and be forgotten. Humanity itself could evolve into an entirely different biological species, or drive itself to extinction. All of this history, all of this time will pass while the most absolute, unstoppable apocalypse in the universe is silently and invisibly speeding toward us through the dark voids of space. And because the destruction travels at the exact speed of the light that would warn us, we would never see it coming. The bizarre rules of the vacuum do not just distort distance, they aggressively warp the physical experience of time itself. To understand this, we must return to the sky's most impossible traveller, the oh my god particle. We know that this single proton struck the atmosphere over Utah with physics-breaking energy. It likely originated from a violent magnetic shockwave inside an active galactic nucleus, or the jet of a supermassive black hole. Regardless of its exact origin, the particle had to cross millions of light-years of empty space to reach us. For the astronomers waiting on Earth, that particle was travelling through the dark, frozen vacuum for millions of years. But Einstein's theory of special relativity dictates that as an object accelerates closer to the speed of light, its own internal experience of time slows down dramatically. Because the oh my god particle was travelling at 99 followed by 23/9% of the speed of light, the time dilation it experienced was nearly absolute. While millions of years agonizingly passed for the galaxies, the stars and the planets observing the particle, the proton itself experienced a radically different reality. In its own frame of reference, time was nearly frozen. From the moment it was violently ejected from its cosmic accelerator to the exact moment it slammed into the oxygen molecules of Earth's atmosphere, the particle experienced a total travel time of roughly 10 seconds. It crossed an unimaginable galactic abyss in the duration of a single short breath, completely untouched by the aging process of the universe. The sheer physical violence of that particle requires another macroscopic analogy to truly grasp. The particle carried exactly 50 joules of kinetic energy. In the macroscopic world of human sports, 50 joules is easy to visualize. Imagine a heavy, solid leather baseball being thrown directly at your head by a professional pitcher at a speed of 100 kilometers per hour. If that baseball hits you, it will shatter bone, cause massive tissue damage, and deliver a brutal, concussive mechanical shock. Now take all of that bone-crushing mechanical violence, all of that dense kinetic energy, and violently compress it down. You must squeeze the energy of that heavy, speeding baseball into a single, microscopic point that is trillions of times smaller than a grain of sand. Alternatively, if you want an even more terrifying scale of energy density, look up at the Sun. The Sun is a monstrous nuclear fusion reactor, converting millions of tons of matter into pure energy every single second. Imagine taking all the raw, blinding nuclear output generated by the entire core of the Sun in one full second. Now imagine taking all of that apocalyptic heat and radiation and successfully compressing it entirely into a single, microscopic drop of water. The resulting density of energy would be so utterly unnatural and hostile that it defies human logic. Yet, the vacuum of space, to comprehend why that slaughter was so absolute, you must understand the terrifying efficiency of antimatter annihilation. Joules. In the classical physics of human warfare, we build nuclear weapons like the atomic bomb dropped on Hiroshima in 1945. That bomb leveled a city and killed tens of thousands of people, yet it was incredibly inefficient. A standard nuclear fission bomb only converts a tiny fraction of 1% of its heavy uranium or plutonium core into actual explosive energy. The vast majority of the bomb's mass is simply blown away as radioactive debris, but the mechanics of the quantum vacuum do not leave debris. When matter meets antimatter, the conversion is completely flawless. The efficiency is exactly 100%. To visualize this, look at a standard small metal paperclip sitting on a desk. It weighs approximately 1 single gram. If you were to theoretically swap out the regular iron atoms in that paperclip for anti-iron atoms, creating a 1 gram paperclip of pure antimatter, the object would become the most dangerous weapon on Earth. The exact millisecond that antimatter paperclip touched the regular oxygen and nitrogen molecules in the air around your desk, it would instantly annihilate. The resulting blast would release exactly 180 trillion joules of pure, unadulterated radiation. The physical destruction unleashed by that single, tiny paperclip would be roughly equivalent to detonating 3 Hiroshima-sized atomic bombs simultaneously in the center of your room. Yet, as terrifying as the energy of antimatter is, it pales in comparison to the apocalyptic mathematics of the vacuum itself. We must return to the vacuum catastrophe, the great humiliation of theoretical physics. The equations of quantum mechanics dictate that the zero-point energy of the vacuum is astronomically huge, while telescopes prove that the actual energy pushing the galaxies apart is incredibly small. The mathematical difference between the theory and the reality is a factor of 10 to the power of 120. To visualize the absolute absurdity of an error this large, imagine a highly skilled master carpenter. You ask this carpenter to precisely measure the length of a standard 1-meter wooden dining table. The carpenter carefully lays down a tape measure, looks at the numbers, and confidently gives you their final measurement. If that carpenter had made the exact same proportional error that quantum physicists made when calculating the energy of the vacuum, the carpenter would not tell you the table is a few centimeters off. The carpenter would not even tell you the table is the size of the Earth, or the size of the solar system. The carpenter would confidently declare that the 1-meter table is trillions upon trillions of times wider than the entire 93 billion light-year expanse of the observable universe. It is a mathematical error so profoundly massive that it completely shatters our confidence in our understanding of reality. This brings us to the final, crushing comparison of scale. The entire theatre of cosmic destruction, from the boiling quantum foam to the advancing bubble walls of the false vacuum, plays out across an unfathomable mathematical divide. The microscopic quantum fluctuations that dictate the stability of the universe operate at the Planck length. This distance is so incredibly small that it is roughly a decimal point followed by 34 zeros and a 1, measured in meters. Conversely, the macroscopic boundary of the observable universe is roughly 10 to the power of 27 meters wide. Between the microscopic boiling foam that anchors your atoms and the macroscopic boundary of the furthest galaxies, there is a staggering divide of over 55 zeros of magnitude. The cosmos is not just vast, it is an infinitely deep sheet of quantum complexity, layered with violent mechanisms that we barely understand. We are trapped in the middle of this scale, completely isolated, surrounded by a vacuum that is actively trying to erase our existence. But that's nothing compared to the massive machines humanity has built to actually measure this madness. Yet these massive machines of discovery aren't entirely what they seem. When you think of astronomy, you usually picture optical telescopes gently collecting starlight on a quiet mountaintop. But to peer into the violent, invisible anatomy of the quantum vacuum, humanity had to abandon standard telescopes. We had to construct aggressive billion-dollar physical traps capable of forcing the vacuum to reveal its darkest secrets. These machines represent the absolute pinnacle of human engineering, yet they simultaneously highlight our terrifying vulnerability and the desperate limits of our technological reach. The most famous of these traps lies buried 100 meters beneath the border of Switzerland and France. The Large Hadron Collider at CERN is a massive 27-kilometer circular vacuum tube where superconducting magnets accelerate protons to a fraction of a percent below the speed of light. When these protons violently smash into each other, they recreate the apocalyptic energy densities of the early universe for a fraction of a nanosecond. Surrounding these collision points are the Atlas and CMS detectors, colossal buildings packed with tens of millions of silicon pixel trackers and supercooled calorimeters. They capture the exploding debris of these collisions frame by microscopic frame. This machine is directly responsible for mapping the precipice of the false vacuum. In 2026, researchers analyzing fresh data from the CMS detector achieved a monumental breakthrough. They measured the mass of the top quark with unprecedented, terrifying precision, pinning it down to exactly 171.77 giga-electron volts. When they mathematically combine this hyperaccurate top quark mass with the mass of the Higgs boson, the mathematical blade of the false vacuum sharpened dramatically. The new data confirms that the universe is not safely resting in a deep energy valley, but is instead balancing on an even narrower, more precarious mathematical razor's edge than previously calculated. However, the machine has a hard physical limit. It simply cannot generate enough raw energy to crack open the Planck scale. To push beyond these limits, CERN is currently designing the Future Circular Collider, a proposed 91-kilometer ring that would dwarf the current collider, aiming to finally tear open the hidden layers of the quantum foam. While CERN smashes particles underground, other machines stare up at the night sky, waiting for the cosmos to fire its own impossible projectiles. The Sinnet-Guzzo, or Fly's Eye Observatory in the Utah desert, pioneered the hunt for ultra-high-energy cosmic rays like the Oh My God particle. Instead of looking at stars, this array of spherical mirrors and photomultiplier tubes looks at the dark atmosphere itself. When a particle carrying hundreds of exaelectron volts slams into the Earth's upper atmosphere, it shatters nitrogen molecules and creates a massive invisible cascade of secondary particles. This collision generates a faint ultraviolet fluorescent waterfall of light that the fly's eye captures in milliseconds. Recent advancements in 2026 by next-generation arrays like the Telescope Array project have begun to map the origins of these violent intruders. Scientists have detected statistical hotspots, suggesting that these extreme projectiles might be firing from the Perseus-Pisces supercluster of galaxies. Despite this incredible tracking ability, the fundamental limit remains. You can see the bullets arriving, and you have a vague idea of which cosmic neighborhood they are coming from, but you still cannot definitively identify the specific magnetic accelerator mechanisms capable of generating such impossible kinetic violence. To solve the paradox of your own existence and the mystery of the missing antimatter, humanity had to place a trap outside the Earth's atmosphere entirely. The Alpha Magnetic Spectrometer, or AMS-02, is a massive 7-ton superconducting magnet bolted directly to the exterior truss of the International Space Station. Orbiting high above the distorting effects of the atmosphere, this machine uses its intense magnetic field to bend incoming cosmic rays. By meticulously tracking the curvature, mass, and electrical charge of billions of electrons and positrons, it hunts for the ghosts of the Big Bang's great annihilation. The machine is specifically looking for heavy anti-nuclei, like antihelium, which would prove that entire hidden galaxies of antimatter managed to survive the cosmic slaughter. In recent reports leading up to 2026, the AMS-02 team has engaged in intense debates over tantalizing yet unconfirmed signals that might represent antihelium particles originating from complex dark matter interactions. However, the machine struggles to capture particles with extreme energies, or those lacking an electrical charge, like neutrinos, meaning the ultimate fate of the missing antimatter remains agonizingly elusive. To understand the macrostructure of the vacuum energy itself, we rely on the Planck satellite. This European Space Agency marvel cooled its sensors down to a fraction of a degree above absolute zero, staring deep into the cosmic microwave background radiation. By mapping microscopic temperature fluctuations, differences as small as 100,000th of a degree, it provided the most detailed map of the early universe ever created. The Planck data cemented the terrifying reality that the intrinsic energy of the vacuum, the dark energy, makes up roughly 68% of the universe, violently pushing the galaxies apart. For years, physicists assumed this dark energy was a static, unchanging cosmological constant. But the year 2026 delivered a massive shock to this foundational belief. The Dark Energy Spectroscopic Instrument, known as DESI, released its highly anticipated second data release, or DR2. The DESI consortium mapped the expansion history of the universe with unprecedented accuracy and found terrifying, robust evidence that dark energy might not be a constant at all. The data strongly suggests that the density of the vacuum energy is actually dynamic, changing and evolving as the universe ages. This completely shatters the static vacuum model proposed by Planck and forces physicists to aggressively rewrite the fundamental equations governing the ultimate long-term fate of the cosmos. To probe the deepest, most ghostly components of the quantum foam, scientists must dive deep underground to escape the noisy radiation of the surface. In Japan, buried a full kilometre beneath a mountain, sits the Super Kamiokande Observatory. This breathtaking machine is a massive cylindrical tank filled with 50,000 tons of ultra-pure water. The dark walls of the tank are lined with over 11,000 golden photomultiplier tubes. These hypersensitive mechanical eyes wait in total darkness for a neutrino, a nearly massless, ghostly particle to randomly strike a water molecule. When this rare collision occurs, it generates a faint, eerie ring of blue Cherenkov radiation. Super Kamiokande is attempting to solve the matter-antimatter asymmetry by studying how neutrinos and antineutrinos spontaneously change their flavors as they travel through space. In 2026, joint data analyses from global neutrino experiments like T2K and NOVA dramatically narrowed the error margins on the parameters governing this specific particle asymmetry. Yet the machine requires scientists to wait years, staring at the blue flashes in the dark water to gather enough statistical data to slowly peel back the layers of this existential mystery. Despite all these monumental engineering triumphs, the ultimate truth is one of profound, crushing helplessness. We can measure the razor-thin margin of the false vacuum, track the impossible energy of the oh my god particle, and watch the dynamic evolution of dark energy. But if a quantum tunneling event triggers a true vacuum decay bubble in a neighbouring star system, our brilliant machines cannot save us. The cold, hard laws of physics dictate an inescapable technological limit, and to run from a bubble wall expanding at the speed of light, humanity would theoretically need to construct a faster-than-light propulsion system, such as an Alcubierre warp drive. This theoretical engine works by violently compressing the space in front of a ship and expanding the space behind it. However, the rigorous mathematics of general relativity prove that operating such a drive requires exotic negative mass energy. To simply power a small ship, you would need a quantity of negative energy that greatly exceeds the total mass of every single star and planet in the entire observable universe. We cannot outrun the quantum vacuum. We are a fragile biological accident, technologically locked inside a metastable prison, armed only with machines that allow us to watch the mechanisms that might eventually destroy us. We have successfully mapped the precipice, calculated the odds, and stared into the boiling abyss of the quantum foam. We know exactly how dangerous the universe is, but what if all of these precise measurements aren't giving us the full picture at all? To understand the terrifying gaps in our knowledge, we must examine the ultimate open questions that keep physicists awake at night. Despite the brilliance of our massive underground colliders and our orbital magnetic spectrometers, the most fundamental mechanisms of the universe completely evade our detection. We have successfully mapped the outer borders of our ignorance, but the dark, uncharted territory lying beyond those borders contains mysteries so profound they threaten to break physics entirely. When scientists push their mathematics to the absolute limit, they hit a solid wall of uncertainty. These mysteries are distilled into three massive unsolved existential questions. The first open question directly concerns the ultimate fate of reality itself. Will the false vacuum actually decay? And if so, when? As we established, the precise masses of the Higgs boson and the top quark mathematically prove that the universe is trapped in a metastable energy valley. The dominant hypothesis dictates that because quantum tunneling is an undeniable physical reality, this false vacuum must eventually collapse. It is simply a matter of probability. However, a fierce, disputed frontier in theoretical physics challenges this doom. Some physicists argue that we are missing a crucial stabilizing force. They hypothesize that unknown quantum gravitational effects at the microscopic Planck scale, or perhaps the hidden mathematics of string theory, might act as an ultimate anchor, permanently freezing the false vacuum in place. The CERN laboratory continues to smash particles to sharpen these mass measurements. They are desperately trying to determine if the cosmos is eternally secure, Or perhaps the true vacuum bomb has already detonated somewhere in the dark, sending an invisible wall of destruction racing toward us at the speed of light. The second open question is perhaps the most intellectually humiliating puzzle in modern science. Why is the cosmological constant so impossibly unnaturally small? We know the mathematical expectation of the vacuum energy was wrong by 120 orders of magnitude. The observable reality proves that this dark energy is incredibly weak, just barely strong enough to gently push the galaxies apart without instantly ripping them to shreds or crushing them into singularities. One leading hypothesis attempts to answer this brutal mathematical discrepancy with the anthropic principle. This principle states that if the vacuum energy had been even a fraction of a percent stronger, galaxies would never have formed, and we would not be here to measure it. Therefore, we can only exist in a universe where the energy is incredibly low. But the more radical, highly disputed string theory interpretation suggests something far more disturbing. It proposes a multiverse containing 10 to the power of 500 different universes, each with a randomly assigned vacuum energy. According to this theory, our universe is not special or finely tuned. You simply won an impossible cosmic lottery in a sea of dead, crushed realities. The third major open question addresses the very origin of your physical body. What exact mechanism triggered the matter and antimatter asymmetry? We know as a confirmed fact that a 1 in a billion imbalance occurred, allowing regular matter to survive the Great Cosmic Annihilation. However, the exact physical trigger that violated this perfect symmetry and allowed you to exist remains completely unknown. One strong hypothesis suggests that during the extreme heat of the early universe, bizarre thermal anomalies called sphalerons aggressively ripped apart the balance of baryons. A competing, fiercely disputed theory argues for leptogenesis, suggesting that super-heavy, right-handed neutrinos decayed asymmetrically first, creating a cascade that eventually led to the survival of the matter we see today. Deep underground in Japan, massive water tanks like the Hyper Kamiokande are actively hunting for clues in the flavor-shifting behavior of neutrinos, trying to catch the exact mathematical violation that gave birth to the physical world. These three open questions represent the absolute limits of human comprehension. We do not know what stabilizes the vacuum, we do not know why the energy of nothingness is so deceptively weak, and we do not know exactly how we survived the primordial annihilation of the Big Bang. We are essentially flying blind through a cosmos that seems violently, fundamentally hostile to our biological existence. Many optimistic scientists comfort themselves by hoping that a future, unified theory of quantum gravity will eventually arrive to neatly resolve all these terrifying paradoxes. They desperately want to prove that the universe is mathematically elegant, perfectly balanced, and inherently stable for all eternity. Except, none of that is true. That ultimate cosmic uncertainty only makes sense once you recognize what we actually are. The universe was not designed as a safe, nurturing cradle for humanity. When we look deeply into the anatomy of the void, the inescapable conclusion is that our existence is an absolute mathematical anomaly. We are the direct descendants of a microscopic cosmic glitch. If the laws of physics had operated with perfect, elegant symmetry during the Big Bang, the outcome would have been brutal. Every particle of matter would have met its antimatter twin in a blinding flash of perfect annihilation, leaving behind an absolutely dead, sterile ocean of light. The only reason you have a body, a planet, and a consciousness is because of a tiny, inexplicable, 1 in a billion rounding error in nature's accounting system. We are not the masters of the cosmos, we are merely the conscious ruins of a broken symmetry. Your entire physical identity is a masterpiece of deception, crafted by the quantum foam. When you reach out and touch your own hand, you instinctively believe you are touching solid biological matter. But as we have uncovered, 99% of the weight you feel is nothing but the ferocious kinetic energy of virtual particles furiously boiling inside your atoms. You're not a solid object moving through an empty vacuum. You are a temporary, highly localized storm of vacuum energy. Your body is a fragile illusion generated by the invisible friction of the Higgs field, desperately holding itself together against the crushing odds of the universe. The terrifying reality of this razor-thin balance is not just theoretical speculation, it is being violently confirmed right now. In 2026, the DC project revealed that the dark energy pushing the vacuum apart is dynamic, actively rewriting the future of the cosmos. Simultaneously, the CMS detector at CERN pinned down the mass of the top quark, mathematically confirming that we are precariously trapped in a metastable false vacuum. Meanwhile, the base experiment successfully trapped antimatter and drove it down a highway in a truck. Humanity is aggressively pulling back the curtain on the most dangerous mechanics in existence. We are finally realizing the true weight of the warning issued by theoretical physicist Sidney Coleman in 1977. Summarizing the doom of the false vacuum, he stated that its decay is the ultimate ecological catastrophe. After the collapse, he warned, "Life as we know it does not simply end." The laws of physics are completely rewritten, meaning chemistry as we know it ceases to exist. This is exactly what the vacuum of space really is, and why it might be the most violent and unstable force in existence. We are balancing on a blade, waiting for the vacuum to finally correct its ancient rounding error. And you? Where in the world are you watching the sky from tonight, and what can you see above your roof? Tell us in the comments, along with the time where you are. If you love wandering through the night sky, subscribe to the channel. That's what keeps this work going. The next episode of The Edges of the Sky takes us to the true size of the universe, a scale beyond human logic. Take care, keep the boiling vacuum in mind, and see you very soon for another journey across the sky.